Hey everyone, this is Kevin from WiBisode.net, and in this webisode, I'm going to do a very short presentation on how to create your own self-signed X509 signing certificate. Now, this is a question that has come into the WiBisode.net mailbag, where developers who are just creating some test software and they want to do digital signatures, and they've asked, how do you create a self-signed certificate? Well, you can Google it and you can find tons of different ways to do it. I've always found that this is easier just to use OpenSSL, and what I'm going to do in this presentation is I'm going to show how to create your own self-signed certificate and encapsulate the certificate and the private key into a PFX file, and then export the public key, and that public key can then be given out to other clients for certificate trusts. I do plan on having a follow-up video where I take the private key and the public key, and then I actually will do a digital signature on an XML document just to kind of show the application on how it works. I'll describe a little bit more about how that works. So anyways, here we go, ladies and gentlemen. So the first thing that I want to do is run out to the internet, and on this server machine that I'm working on here, I don't have OpenSSL installed on it yet, but what I'm going to do is go through the process of doing that. All right, so I'm just going to Google it. I'm just going to search for download OpenSSL, and let's look for the SSL binary distributions. And in this particular case, I'm using Windows. If you're using Linux, you can use Aptitude to get it if you're using Debian or Yum or whatever you would use to install it in Linux. So let's go to here. And you'll see that there are multiple distributions, though I typically go for the full version. There's like the light version, but I'm hardcore, right? So I go for the full version. So this is the first instance of the full version, Windows 32-bit OpenSSL version 1.blah. And I typically know that it's full version because it's a bigger archive or a bigger installer file. Just go ahead and download this executable. Awesome. And then let's launch it. All right, so we'll just follow this through like a regular Windows installer. Next, I accept. Next, see OpenSSL, that's perfectly fine for my purposes, and I'm not going to worry about copying the SSL DLLs to a different Windows system folder because I'm not going to be using them, so the OpenSSL binary folder is perfectly fine. Next, install, here we go. Cool, and I would like to donate, but some other time, guys. All right, wonderful. Here we go. So the next step is going to be that I'm going to, just like we would normally do, I'm going to run out to here and go to the bin folder. And I'm going to put this in our system path, just like we've done with our other tutorials. So right click on this PC, go to Properties, Advanced System Settings, and then Environment Variables, and then Path, Edit, go to the end, semicolon, paste. All right, okay. And we should be in shape at this point to start using it. So let's open up a command prompt. All right, and I'm just going to run out to the desktop. That way we can see the files showing up on the desktop there. All right, so if I just type OpenSSL, oops, if I can spell it correctly. Cool, I can actually see that OpenSSL, the prompt is actually showing up, which is fantastic. All right, so let's go through the process of creating a simple X509 certificate that we will be using for digital signatures. We'll do an OpenSSL and then the REQ-X509, and then the number of days that this is going to be, until this expires. We'll just do like 365. So this is going to expire in a year from this date. Dash new key RSA, and then however many bits you want to use, which 2048 seems to be pretty decent, and then the dash key outs. And I'm sorry that we're actually losing this. Let me see if can I make this bigger? Let me see if I can do this real quick. All right, so we'll try to work with this. I have my scrolly thing here so we can follow this out. All right, anyways, let's continue. OpenSSL. So REQ means that this is a certificate request, and it's an X509 certificate that's going to be available, so it's not going to expire for 365 days. New key means that we're going to make a new certificate, and then RSA to 1T48 bits. So key out is going to be the key file. So this is going to be what stores our key. So we'll just call this my cert.pen. And then let's then do out. This will be my key.pem, and now let's push the cert out to dash out. This will be my cert.pem. All right, so that's going to make us go through this process of creating stuff and adding stuff. So let's just create a password for this. I'll just make it something simple for me. I'll just call it 1 2 3 4 5 6 7 8 9 0. It's going to make me confirm it. 1 2 3 4 5 6 7 8 9 0. Okay, so the country name, I'll just say United States. The state, DC. The city, we'll call it Washington. Organization name, so the company name, we'll just call this WiBisode.net in my case. Organizational unit, we'll just call this software engineering. Common name, we'll just do www.wibit.net. Email address, support@wibit.net. All right, so now if I look at my desktop, look at this. I have a PEM file and a PEM file. So I have my key and my cert. So now let's put this into a PFX file. So we'll have both of them in a single file. And we can do this very easily. Open SSL, PKCS12-exports. So we're going to export. The input is going to be, first we'll do the cert file. So this will be my cert.pem. And then the in key is going to be my key.pem. And I'm going to push this out to WiBisode test certs.pfx. All right, so it's going to go through this. It wants me to put in my password that I locked it with, 12345678990, and then it wants me to create an export so that the PFX file has a password on it. Now I'll just go ahead and use the same password, 12345678990. Enter it again, 12345678990. Boom. Shaka. All right, so at this point, what I can do, I can actually just take these two files. I can keep them, and I should keep them, but for the purposes of this, I'm going to delete them because all that I'm going to be doing is working with this. So what I can do is if I'm creating a digital signature, I can use the private key it's installed, that's encapsulated here, to sign my document, and then I could use the public key to verify the signature. So what I'm going to do now is I will export a public key, and then I will end this video with the PFX file in one hand. This will be me. I keep this as the secret person, as you know, the person that wants to establish the trust. I will keep this, and then the public key will be what I can hand out to my clients. And then we'll come back at a later time and we'll actually do a digital signature. So here we go. Let's actually export a public key. Open SSL, and then we'll do PKCS12, and then the input is going to be the PFX file -cl certs -no keys -outs, and then we'll just call this test cert public.pem. All right, enter the import password 12345678990, and it's good to go. So we'll minimize this. Here we go. Here is my public, and here's my PFX that contains both my public and my private. So that's how you can make a simple X509 signing certificate, public and private, for your digital signatures.